Good afternoon, everybody. My name is Mayuko Inoue. I am a third-year undergraduate student here at UCSD. I'm pursuing my Bachelor of Science in Computer Science. I've had the pleasure of being part of the internship program here for IDASH this summer. My mentors were Ji-Hoon Kim and Dr. Lucilla Ono Machado. My presentation today is about the visualization of microRNA sequence data analysis. So today I'm going to talk to you a little bit about Kawasaki disease, microRNA, MIRAGE, interactive technologies that I learned and used throughout my project. So for IDASH, one of the driving biological projects is Kawasaki disease. Of course, Dr. Jane Burns and Dr. Chisato Shimizu has been doing extensive research here at UCSD for this disease. But just a small background, it is the inflammation of blood vessels, and it's a disease most commonly found in children. So the research that Dr. Burns and Dr. Shimizu has been conducting is looking at microRNA sequencing of Kawasaki disease patients to identify patterns in acute versus convalescent patients. So what exactly is microRNA? MicroRNA are small non-coding RNAs. They're about 22 to 25 bases long, and they're characterized by their hairpin precursors composed of the mature, the loop, and the star microRNA, as you can see in this diagram here. MicroRNAs are very important in regulating protein expression, so a lot of researchers look at them in order to diagnose and do research on cancer and Kawasaki disease, as I said before. So the IDASH team here has developed a tool in order to be able to analyze and present the data for researchers who'd like to do research on cancer and Kawasaki disease, and they've developed this tool called MIRAGE, which stands for microRNA analysis in a GPU environment. Basically, what it does is that the user inputs data, and it runs through a pipeline and displays data in a graphical format. This is a little snapshot here of the front page of MIRAGE. The IDASH team here has done extensive work on the back end to create the pipeline, and I have been working on the front end in order to be able to display the data that the user has inputted. So currently, there is a front end to MIRAGE. However, there's a number of setbacks that prevent it from being what it really could be and be really helpful to the researchers. So these 4 diagrams here are a couple examples of the diagrams on the current website. But the graphs, a couple setbacks are that the graphs are not directly generated through MIRAGE. Right now they're created through R, and so they're still images, you can't interact with them. As seen in this second bullet point here, there's difficulty in identifying and looking at the specific data points on the graph because you can't select and you can't see what data you'd like to see, even if it is statistically significant for the research. Also, there's large amounts of data, which makes it very difficult to compare the data and actually see what is significant, what's different about, acute versus convalescent patient data. Also, the user cannot specifically choose or sort through the data to view, so they cannot filter out what's insignificant versus significant. So in order to address these setbacks, I learned a variety of tools in order to create the front-end MIRAGE to be better. So these are a couple of the tools that I've learned and used so far. AJAX is a web development technique used on the client side to create asynchronous web applications. This was very important because the user was able to interact with the data and be able to see and toggle what they'd like to see, what they don't like to see. They can pick and choose what exactly they'd like to see in order to analyze their data. Also, I use JavaScript, which is a scripting language that allows for interactive web applications. There's a variety of libraries in JavaScript, most commonly jQuery and JQuery, which I utilized in order to create the front end of MIRAGE. They're both JavaScript libraries that allow for interactive features that make it easier for the user to use the web application. Also, I used 2 libraries called Canvas Express and HighCharts, which were mainly used for the graphing visualizations. Canvas Express is a library created for biologists, and so their tools, such as the genome browser or the network plot, make it very easy for researchers to see their data and fit our needs for the MIRAGE tool. Also, HighCharts is a very generic, yet very interactive and useful tool that I used to implement. Both of these libraries used a data structure called JavaScript Object Notation, a JSON data structure. I got to know these very well in order to be able to use Canvas Express and HighCharts. Of course, in order to use these tools, I needed to use PHP so that the tools can read the data directly that the researchers had implemented. This was essential so that it would fit each researcher's needs and their data would actually show up on the page, of course. And like any web application, I had to use CSS in order to make the web page pretty and easy to look at. Very, very nice layout. So these are a couple of the visualization examples. So I went to a couple meetings with my mentor to talk to Dr. Burns and Dr. Shimizu about what they'd like to see. So in the end, it was kind of an end user meeting. One of the things that they said they'd like to see was an overlay for anomaly detection for base quality. So I created this graph here. So it overlays the base quality of different patients. You're allowed to pick and choose which lines you'd like to see, so you can compare versus acute versus convalescent patients, as well as hover over the points in order to see specific data. Also, this is another example of a distribution of read length. There's one graph per patient, but this is another anomaly detection in order to make sure that the data that the researchers inputted does work, because they should see a peak at 22. Also, another concern that Dr. Burns and Dr. Shimizu said that they'd like to see is to be able to threshold the data for differential expression for microRNA. And so I inserted a filter for this table here because they said they would like to see microRNA with a p-value of less than 0.05 because they find that to be very statistically significant for their data. These are graphs that I generated using Canvas Express. The first is a network plot for microRNA, and the second is a read length. And so these are very helpful tools that many biologists can use in order to see their data. So a couple lessons that I've learned from doing this internship and talking with many of the people here, going to the end user meetings, talking with my mentor. So some of those were discovering and implementing new technologies to enhance the web application. I hadn't known any of these libraries from before, but I found them to be very useful, and I'm hoping that, and I've gotten some feedback, and they said it's pretty useful so far. I found that the collaboration between clinicians and developers is very essential, because I need to know what they want to see so that I can fit their needs when creating the front end. And I hope that the tool will be readily available to all clinicians to use in the medical field in the future. Lastly, I'd like to acknowledge the whole team here. Of course, my mentors, Ji-Hoon Kim and Dr. Ono Machado, Petra Stepanovsky and Stefan Bruno for creating a big part of the back end for MIRAGE, so I can figure out how it's working in the back end. Of course, Claudia Farkas, Jane Burns, Shata Shimizu, Nate Heinzman for organizing the I-Dash internship, Cali T2, I-Dash and DBMI, and of course, NIH for funding the project. Thank you very much, and I can take any questions.
While we're preparing for questions, if the next speaker could get ready to come down.
I just had a very nice talk. I had a question regarding your choice of using Canvas Express versus something like SiteEscape,
Yes.
which is a nice Java-based visualization tool that has like extensive plugins and visualization options and things like that.
Sorry, what was it called?
A SiteEscape.
Cytoscape?
Cytoscape.
Cytoscape.
It was created by Trey Eidecker, and he's here on campus.
Okay,
so
great.
you should think about that.
Okay, I will. Thank you very much.